listening to Future in Steel, a podcast series about the composite revolution. Brought to you by Composites, winner of the 2025 Chamber of Commerce Innovation Award. Hear how challenges, vision and real-world innovation meet. How leading Dutch companies, innovators and key stakeholders share their vision on the future of industry, steel and manufacturing, strengthening Europe's position as a global economic power in a rapidly shifting geopolitical landscape. Glad you're listening. Welcome to a new episode of Future in Steel, the podcast series exploring the technologies shaping the next generation of industrial structures. Today, with a very special guest, Chris Skinner, Vice President of Strategic Marketing and R&D for Owens Corning Composite Business, where Owens Corning is the world's leading innovator in glass fiber reinforcements and composite material, with decades of experience in developing high-performance materials for industries ranging from construction and infrastructure to renewable energy. At the latest JEC World in Paris, Owens Corning and Composites signed a Memorandum of Understanding to explore how their expertise can be combined to optimize glass solutions for large-scale composite joints. Hear from Chris and Maxim Segeren of Composites what that means and why strengthening the material ecosystem around composite is an important step towards a large-scale deployment of this technology. Chris, on behalf of Maxim, a very great welcome in Future in Steel. Great to have you.
Thank you. It's an honor to be here in a wonderful day in The Hague.
In The Hague, we record this in The Hague, and indeed, the sun is shining, both on the outside and in our hearts as well, of course. Yeah. Maxime.
Yes. Chris, thanks for joining this podcast series. I'm really happy to be here today and talk a bit about what we're going to do the next few years. And one of the things, of course, which I think we would start off is with who is Chris and how did you come to this business and what does Owens Corning do?
My story is kind of a bit of a traditional one. I mean, I grew up in the UK. I went to college in the UK. I studied chemistry. I did a PhD in chemistry, and then basically I started to kind of progress through the world of material science. I worked in catalysts, I worked in polyurethanes, I worked in polyamide, and then 16 years ago I joined Owens Corning. I've done a number of jobs in Owens Corning. I've worked in the fabrics business, I worked in the composites business, I worked in the corporate environment. And now I have a role where basically my responsibility is to really think about what the future of the composites industry looks like. How do we shape our offer for the customers? And how do we actually support growth and adoption of composites? I mean, it's a super cool job. I get to do all kinds of crazy things all day, like sit in a room in The Hague and talk about, composite adoption. What's Owens Corning? Owens Corning was formed about 90 years ago. And it's really one of the most interesting things to actually read about. I mean, basically, it started with Owens, Illinois, and Corning glass, where basically some scientists had actually kind of extruded glass through a platinum bushing and created a fiber. And traditionally nowadays, you would say to the scientists, "Stop that. Go back to work and do what you should be doing." And basically what they did 90 years ago, they said, well, that looks super cool. Why don't we turn that into an industry? Mm-hmm. And essentially then in 1937 or 1939, Owens Corning was formed from this kind of this integration between Owens, Illinois and Corning glass. And essentially what they did is they created an industry. So they invented continuous roving, they invented chopped fiber, they invented SMC, they invented pultrusion. So if you read through the history of this company, it's completely nuts. It's completely nuts. If you see what they did, it's completely nuts. So, I mean, not wishing
pioneering.
Yeah, I mean, it's incredible. So, I mean, not wishing to plug a book that we recently published, but we wrote a book recently with Inkles van Post from Leuven about the history of composites. And I got the honor of writing chapter number 1 on the history of glass fiber.
Wow.
And actually so we went back into the history and pulled all the stuff out and wrote the story. It's insane. You'd never get away with it these days. I mean, to read it, it's really quite interesting. So I work for Owens Corning. We're one of the world's largest glass fiber producers. We produce glass and product in like 17 countries, and it's being part of an industry that's dynamic. It's about material substitution. It's about creating growth. And really, that's the kind of role that we look to play in this industry, which is the company that's kind of supporting the development of this industry. And I think it's an honor in many of these places to actually do this.
Yeah.
Yeah.
Wow. That's special. We have a special guest here today with a special company.
Yeah, I knew, but to hear all of these details is way more exciting. But indeed, you wrote the first chapter, and then you were like, okay, super happy about let's say the content, and you said, okay, just now, and I find that very interesting. Today, that would not be possible. Right, all of these pioneering steps.
I mean, because
why?
You live in this world,
yeah,
right? Which is okay. Can you imagine going to someone and say, "Oh, I've got an idea. What's the idea?" Well, I'm going to create an industry based on something that doesn't exist, but I've got to invent a whole bunch of process technology to make it work, but I don't know how to do it. Right?
Pretty wild.
So it's like the Apollo moon thing. It's like, oh, we need to invent the transistor to make it work. So when you look at it in terms of what they did, it's incredible to read. And I have to have a shout out to the lady that wrote the chapter with me, which is Michelle Corwin-Evanson, because Ignis phoned me up and said, "Oh, would you write the chapter?" And I said, "Yeah, I'll do that."
Mm.
And then you realize what a nightmare it is. And it's like, I need someone that's going to help me. So I phoned Michelle, who's one of the scientists that work in the R&D group I have in the US. And she did a tremendous job of actually going through and actually reading and pulling all the original documents out. And then we kind of put it together and wrote it. So I have to say a shout out to Michelle on this one.
Okay. But yeah, no. When you say that, okay, I think we do a mini version of what is, because of course we are also trying to create a new market.
Well, that's basically what we're doing.
Or a new industry, right? Yeah. But yeah, so I feel the challenge, right? And then. No, well, so one of the things that I think would be interesting. So, of course, we're doing quite some innovations on the structural aspect, mainly then on how you apply, let's say, the material. But from the material side, you also see that there have been innovations over time. Where can you a little bit, let's say, explain what you see the last, let's say, 15 years, and how does that impact, let's say, what we do right now?
I think it's always an interesting question about how do you think about composites, right? And I joined this 16 years ago, and you have to find ways to think about the benefit of composites, right? And I think simply for me, I think about it in two specific areas. I talk about specific modulus per dollar and specific strength per dollar. Right? And everyone goes, well, why is that important? Okay, specific modulus per dollar means that you actually look at it and say, okay, for every unit of modulus, how much weight does it take to deliver it? And how much cost does it take to deliver it? And really, this is the key trend you look at. And you go, look, okay, the composites industry is driven by material substitution. And to achieve material substitution, you actually have to offer a value proposition that's beneficial versus the incumbent material. So if you think about it and say, okay, if I want to drive the substitution of metal, or I want to drive the substitution of wood, or I want to drive the substitution of aluminium, essentially you get into a conversation about specific modulus or specific strength per dollar. And if you look at the trend in the industry over many years, it's been really how do you actually move those numbers? So, I mean, I'm trying to think when did I do it? I mean, we launched in China in 2011. We launched high modulus glass for use in wind energy. Now, okay, glass in high modulus glass or higher modulus glass was used in advance by one producer. But actually, we launched and we started to commercialize the large-scale adoption of high modulus glass. Why do we do that? Specific modulus per dollar is better, right? What's the consequence? Basically, all wind blades in the world are made with high modulus glass now.
So in that, because the high modulus, does it actually do to a blade? It allows for a bigger deflection, or what?
Yeah, so I mean, when you look at a blade, I mean, basically, what are you doing? You're building essentially a sail, right? So I mean, essentially, if you look at it, I mean, basically, as a blade, when it spins, it's subjected to a force and it bends. If it bends too much, when it spins, it cuts the tower off.
Yeah.
Right. So your choice to actually deal with the ability to make the blade longer is I've got to provide more stiffness. I can provide more stiffness by making the blade bigger and heavier.
Mm-hmm.
That's bad.
Yeah.
Or I make the material more stiff and I get the same performance with the same weight. I can make a longer blade with the same weight. So really this point about specific modulus per dollar correlates to AEP.
Yeah. So it's stiffer.
Stiffer, you make
unit.
it longer.
Yeah.
IR squared, the swept area is longer. As
Yeah.
a consequence, you get more energy per unit of glass, basically.
Yeah.
But then would you agree that without this development, we would be stuck in upscaling wind turbines?
I think we wouldn't.
In high modulus glass, right?
Yeah, I mean, I think you look at it now. I mean, if you look at the systems now that are in place, I mean, basically you see the use of carbon, you see the use of high modulus glass. Why don't you build bigger, more efficient turbines? I mean, you'd probably be stuck at. I mean, always the discussion was how long could you make a turbine, right?
Yeah.
So you would actually probably limit the length that would be possible. Right. I mean, there's probably loads of wind energy engineers disagreeing with what I'm saying now.
Yeah.
Right. But I mean, simply for me, specific modulus per dollar, the better it is, the longer the blade, and the more energy produced, the more competitive it gets.
Yeah. No, I think that more or less answers why does glass fiber provide such a powerful reinforcement material, right?
And I think, if you think about your application and stuff like that, it's the same sort of thing. I mean, I think you get into this question of specific modulus or specific strength per dollar, and it provides a view of how to make a decision.
Yeah.
And I think historically, you've always had this challenge in composites where people have really looked at, I'm going to think about total life cycle cost of the product, and I'm going to sell it on the grounds that, it's going to last for 100 years versus 20, which is a compelling argument. A compelling argument of specific modulus per dollar, specific strength per dollar at the point of use is much easier to sell.
No. Yeah. I'm just thinking about our, it's a little bit more complex.
Yes.
But no, indeed for us, so we use indeed your glass. Super happy with it. Really gives us performances that allows also the structure to indeed reduce tremendous amount of steel. And at the same time, we also know that, there's still room to improvement. And that's also, I think, one of the things that I'm so excited about for the next coming years.
Yeah. But you're really making a difference in every aspect, because the things you're doing, you're developing the longer blades and stuff like that. But that technology or that way of thinking enables you to even explore all kinds of applications in which these materials can be used, isn't it?
I mean, but it's an interesting question, right? I mean, one of the challenges we have as an industry is the composites industry is still relatively small, right? I mean, I'm not sure how many millions of tons of steel are used or produced every year, but it's quite a lot, right?
Yeah.
I mean, if you think about the composites industry, I mean, the amount of glass and carbon put together is probably 8.5 million tons globally, right? So it's a big industry, but it's a small industry at the same time. And I think really one of the challenges you have is that you have to think about what's going to drive the large-scale adoption of composites. And to get large-scale adoption of composites, you have to think about applications that you can substitute that are going to make a difference. I mean, wind is the single largest application for composites, right? You can't build a wind blade out of anything else apart from composites.
No.
But I think, if you take your case, it has the potential to be a massive application for composites, but what's it take? It requires material science that's actually leading and clearly better to drive material substitution than the incumbent material.
Yeah.
But it also requires a supply chain to deliver it.
Yep.
And this is one of the challenges with composites is you actually have to configure a supply chain that's actually scaled versus the application. And that's one of the other questions you have within the composites industry, which is why, we spend a lot of time trying to figure out how to support this thing, because a bunch of small-scale producers producing small things is not going to create a huge industry. Someone substituting steel in offshore wind platforms, that's going to make a big difference to the composites industry.
Yeah. No, I agree. And we more and more, I think it's also what I fully agree on. Is that was also the reason why I was so excited about it, because I saw, of course, when we started, we said, okay, this works, but we still have to bring it to the market, all the uncertainties. But I also always said that, okay, if we make it, it will be like, not big is mildly said, right? So it would be such a major shift, or it would be too radical to adopt. And I'm now thinking, okay, too radical adopt, that will be fine. It's just, how do we innovate fast enough, I think, and also deployment offshore. But we also at JEC, we had really a good week. Lots of actually other applications, and that's I think also the power of this technology, that it is not limited. Although it has the highest impact on steel, let's say heavily loaded structures, it also enables full composite structures, right? Because we were talking to a party that actually, hey, I want to connect tubulars of composite, and I was really struggling because there are no structural joints. There are only joints for media. Let's say when you have pressure vessels, and he was like, you solved it. We should talk. And
Eureka!
Yeah, no, and also, so we were talking about let's say large scale, but also on really small, let's say lattice type of structures. You can think of all kinds of applications to make things lighter, but also sometimes more durable. So I was really okay. For me, it's like, okay, it's just we have to make choices, but we have to find one way to, let's say, expand the entire, let's say, applications. And we should also look at two, let's say, paths and scenarios. And okay, if offshore wind takes off fast, then we indeed need to grow fast in volumes. But there are also, let's say, other scenarios where we, let's say, in other markets besides offshore wind, can grow. And I also see that, and that's why I'm also so happy that we can only do this in partnerships and together.
Of course. Yeah.
And I also think, okay, of course, I know you're excited, but I also I was still thinking about, okay, when you first saw, let's say, this crazy ideas of us. I'm just curious on what you at that point in time thought. Did you think, yes, this is possible, or did you think, well, quite skeptical about it? But
no, I mean, I think if we go back, I think I first saw you at the JEC Startup Booster event 2 years ago.
Maybe 3 years.
3 years ago.
Time flies when you're having fun, Chris.
3 years ago.
Yeah.
No, but I think there's always that point about when someone puts something in front of you that is clear. I mean, I don't want to use the word simple, right? But you look at it and go, all right, what's the proposition? Okay, I'm actually going to replace a welded joint with a composite joint, and I'm basically going to enable a redesign of the structure that's going to save weight and add durability. You look at it and go, holy moly, that's amazing, right? And I see a lot. I mean, with the JEC Startup Boost, the way it works is I read it. Well, we get about 130 to 150 cases to read in December, and then you rank them, and then we produce 20, and then we have the competition, right? And I read yours. Okay, 1 minute, easy. Yeah. Put it on the acceptance part because this is too good to, Yeah. And then I think the way you presented it, I mean, it's like it's so compelling. And you look at it and go, well, the science is right. If the science is right at the point of use, let alone the life cycle cost.
Yeah. So
you look at it and go, it's a truly compelling case about how to actually create a material substitution. And I think, it's really interesting for me because I read a lot. I mean, you read a lot, blockchain and mycelium and blah, 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 and lots of stuff like this. And you look at it and go, okay, it's the pure capability of a composite in substituting a material, and basically it enables a transformation of a market. I mean, it's super elegant, honestly. So congratulations, and you pitched it so well as well, right?
Okay, thanks, right. Thanks a lot.
Well done.
Yeah, because it's always I think a challenge to actually to meet, because you can tell so much about what you're doing, and then just to select, okay, what are the most relevant parts to pitch. And I do remember that at a certain point, I think Jelle from Airbus,
yeah.
He asked me, but what is the major challenge that you have? And I was like, yeah, it's not technology actually, right? It's because we know that the technology works, and it was more of an, okay, how do we get to the scale of actually when it picks up, then you really need to scale fast, but also then all the, let's say, what we see is indeed the adoption goes hand in hand with, let's say, the true belief that it is a reliable product, but also that there's a reliable supply chain. Because in offshore wind, and also I think with blades, they have this really, it needs to be in time. So that means that you have to have a reliable supply chain. And I said, okay, of course, that's why we were at JEC, right, to find the partners. And now, a little bit more than 1.5 years ago, I think, I'm truly I see that we're starting de-risking all of those challenges. So
it's always interesting. So on the panel of the JEC startup booth, we have Jelle Blumhoff from Airbus.
Okay.
And he's a wonderful guy, right? Because Airbus knows everything about composites. I mean, I'm not joking. They know everything about composites because every joining technology, forming technology, layup technology they've done and they know.
They've tested and
they know, right?
Yeah.
So you have this wonderful experience of sitting in a room with Jelle and it's like, yeah, done that, no. Yeah, done that, no. Yeah, done that, no. True composites, yeah, absolutely clear. Next, move on. So if Jelle says yes, it's good for me.
Then you got something. Yeah. I wondered, not being a technician or a scientist, Chris, is the world of steel ready for this application?
I think it's always an interesting question, right? Because I sit in many rooms and people talk about, steel's going to be threatened by this, or composite rebar. Steel's going to be threatened by composite rebar, and I think the opposite is true. I think in some respects, steel's enabled by these technologies, right? Because if you look at it and go, look, there's not enough glass in the world to replace all steel rebar. Mm-hmm. There are applications for steel rebar that you will make in steel rebar, right? You'll never change it to a composite. But I mean, okay, you take a seawall, right? Why would you make a seawall with a material that rusts? Mm-hmm. Right? Use a composite. It'll lead to durability. So I kind of look at it and go, I think there's almost a symbiotic relationship or something that could be symbiotic where if you've got big challenges, use the best material for the challenge, right? You want a black steel rebar to reinforce a floor somewhere, just use black steel. Why would you use composite? It makes no sense, right? And I think in the case of the offshore thing, I mean, I think in some respects, anything that can make offshore wind more competitive and lower cost is good for steel and it's good for composites. So I think in some respects we always say, people sit and say, we're in direct competition with steel. I don't think we are. I think we've got the opportunity to be symbiotic and actually kind of reinforce and improve the relationship between the two materials. And I think it's interesting in some areas of the world, you see steel companies taking up composites and actually selling composite solutions.
Yeah.
Which is actually a logical thing to do if you think about it really.
Yeah.
So I think for me, I always encourage people, this isn't a war between composites and steel. This is about how to deliver a material solution that enables growth.
Yeah.
That's the key point.
And that's a story that has to be told.
No, but I fully agree. And that's also, it reminds me when we first talked to ArcelorMittal and we explain what we do. And then we say, we decrease the steel. And then they have to sell it to management, right? And they're like, we're going to use less steel, but then we're going to deploy more. So eventually it's more steel. And otherwise there will be less steel because then there are troubles with the business case whatsoever. And that was like, okay, so we're going to support something that will enable less steel. Yeah, okay. So you had to really explain that, okay, if we do this, then it also accelerates the deployment or at least the rates of which we can make structures. And I think it's also something that that is not often told is that the first 25 years of this century deployed, let's say, 10% of our ambition of 300 gigawatts offshore. And the next 25 years, we have to do the other 90, right? So it's not always about, cost effectiveness, but also about the speed. Because I think now also what we're currently seeing is that the ability to produce your own electricity, pays off, right? Recently I saw again a person who looks into, let's say, the effects of financial effects of rising gas prices, and 1 trillion also was spent on making or keeping electricity affordable in Europe in 2022, because we had such a high rise, which is more or less the amount that we need to realize the energy transition. So we spend 1 year more or less what we want to spend in the next 25 years, and then we say, yeah, offshore wind is too expensive. Well, not if you take this into account, that whenever a geopolitical situation like this occurs, right, then we actually are paying the bill of not actually speeding this up. And I think that's the true challenge within Europe, to get everybody on the board, as in, okay, let's speed up, instead of looking only at, okay, we cannot pay for, let's say, enabling this. So I'm happy with the change, but I think we should repeat it more. And then another thing that I think is very important to realize is that what we now bring to the table with our technology is that's not only, let's say, making new stuff, and it's also something that popped up recently, also more in the Netherlands in the news, is that we have huge amount of civil structures with lots of welds, which are getting to the end of life. And we have a choice we don't have a choice, actually. We need to either repair them, which with welds, it just means more or less you have to replace the entire thing. But now it's not new, like strengthening structures with composite is not new. But I think what we bring to the table, that we actually can offer a reliability in it. We can actually predict what the extension of lifetime is. So last week there was this article about that we have 50 to 80 billion of backlog of only in the Netherlands.
Yeah.
And with Minister Karremans in front of the, let's say, the the storm arms, and then I see huge amount of welds there, and I think, if that is running out of its lifetime, let's go and have a talk, because we actually could reinforce and actually save society huge amount of investments of replacing it with all risk involved. So I'm and this is where I also get really excited, because then it just is. So the technology is so versatile, and it's also and it's even like we can so much do more in material selections as well. So I just see it as, okay, I'm quite excited and like to move forward on this.
And Chris, you will be talking about supply chain. If we talk about this, if we talk about a European autonomy, there's a lot to be done here. Isn't that right?
There's a lot to be done. And I think if you look at the relative rates of penetration of composite in end-use markets like aerospace or automotive or wind or construction infrastructure, the lowest levels of penetration of composites is construction and infrastructure, right? Because I think people always gravitate towards cars, or they gravitate towards sporting goods.
Yeah,
really, the true power of composites sits in infrastructure.
Yeah,
and construction,
because it has to, and I fully agree, because it has to last.
Yes,
right. And welds are just not there to last. They are the Achilles heel of every structure, so that you weld, and so yeah.
Is there a tipping point with regard to this, that where adaptation and thinking is taking on?
I think, it's a really interesting question, because people ask me all the time, how do we drive the penetration of composites in building construction infrastructure? And and I think I've seen it in many different countries, and I think you look at stuff like, many years ago, we purchased a rebar business in North America, and we worked at figuring out how to actually drive adoption of composite rebar in North America. And you ended up in an environment where we had some DOTs who are actually relatively forward-thinking, right? So, I think the Florida DOT is probably the most forward-thinking, transport authority that you'll see. They have hundreds of bridges, hundreds and hundreds and hundreds of bridges, and they're all in salty water.
Yeah.
Guess what's happening to them?
Yeah.
Right? So, I mean, okay, you've got repair or you've got replacement, but I mean, they got to the point where they actually spec'd and said, okay, we're not going to build with steel in the bridge decks anymore because it's a disaster, right? So you saw people adopting this technology, but I think, I always say that the first discussion that people have, and they say, oh, we need to educate people at university about the use of composites. And I say, well, I'm not sure I agree with that, because I think basically an engineer is a rational being. It's probably the definition of a rational being. If you have a standard and specification that enables you to use a composite material and it's clear about the use case and the benefit of the material, someone will select it. And I think in some questions, it's more about the standards and specifications that allowing the use of composite materials across a broad range of applications, which will change. And I think you start to see it in certain areas where these specifications and standards are emerging, which are allowing people to make the choice.
Yeah.
And I think that's really the key question you get to. Because if you say, I need to educate people in universities, it's a long journey to material adoption.
Exactly. But the thing that strikes me, it's all pure logic. If you look at, cost, if you look at applications, if you look at durability and stuff like that, CO2 emission and all this stuff, it's pure logic.
Yeah, and it reminds me of a story that Marcus Kramer of Airborne said it. What if composite would be there first, right?
Yeah.
And you then would say, I have a new material. It's steel. And we need to dig it up. And we have to make big factories to melt it. And then big factories to make it into products. And then you would ask, okay, and does it work? Does it then? You have to be careful with water, because then... And if you look at just that storyline, is that if you would have composites first, you would probably never see steel happening. But yeah, that is just...
but you have to be cost effective.
Yeah.
This is the key question. You have to be cost effective.
And that's why I believe in this hybrid, where you use steel in its, let's say, in its highest value. That's just stiffness over dollar, maybe. That's... normally I say kilograms, but I think steel is the best stiffness supplier that you can buy, but it is prone to indeed corrosive environments. It's prone when you heat it up with welds. So if you then combine that with, let's say, not deteriorating the material, then I think you have the best of two worlds, isn't it?
It's symbiotic.
Yeah.
Yeah, it's symbiotic. I mean, I think it's a change in mindset. I mean, I think if you get away from the point about I need to substitute it, but I actually change the mindset and say I actually need to figure out how these materials work in the best way. There you go.
Yeah, and I think one of the so we target, of course, these high steel structures, but what I also still believe that for composite is a let's say a future market, because it's not a mature market. It's floating structures, and as in floating wind. It doesn't make sense to make them fully out of steel, because it needs to be light and it needs to last. But then how to make these? Well, these are really gigantic,
massive things,
and where can composite play a role? And I think we start to, and I think there we can do a lot. And also at JEC was also this. I think it was one guy who said, "Yeah, we're going to build with Google data centers offshore." And I'm like, all right, but then they need to be, let's say, long lasting, right? Because if you do that with steel structures only, then so this is another follow up that we
sure. You signed a memorandum of understanding. Could you elaborate a bit on that? What that means?
Yeah, for us it is okay. We what we want to achieve is large volumes as well. And then when you really start to look into the numbers and see, okay, how are you going to do that? We initially thought, we have to do everything because everything what we do is unique. And then you build your business case, your investment plan, and then you start to talk to indeed partners, and you realize, well, actually there are people who could actually help us, and instead of doing everything yourself, you're actually going to look at partners where you, let's say, can grow faster, but also be a more reliable party. And then I think it is a result of 12 months of talks about how could we collaborate and what can we mean for each other. And I think I'm truly happy that we get to this understanding that actually we can do that, right? So that's what it means for. I think for Tree Composites is just it shows that we are really serious about scaling.
Chris?
Yeah, I mean, for me, it's a funny story. I was in Oslo Airport speaking to Maxim and his team on a video call.
Okay.
And we were talking about the requirement to help them grow. And he said, hey, I need this money to do this. I said, well, yeah, but we do this already.
Okay.
What? You do this already? I said, yeah, we do this already, and we do it at a big scale, right? In a different market, basically in the wind energy market. So, I mean, it makes sense for us to actually help you through this process. I mean, I look at it and go, look, no one company can create a transformation like this. It's going to take a village of people. It's going to take, it's going to take us. It's going to take Tree. It's going to take other people to actually kind of do this thing. So, I mean, really, there's this point about how do you optimize the material? How do you optimize the supply chain? And then how do you deploy?
Yeah.
And I think my view of this is that we can play a role to help Tree through this process, and we can play a role to help the other parties through this process as well, because I think at the end of the day, the most important thing is the technology is adopted.
Yeah.
Right? I mean, that for me is the key point. If the technology is adopted, okay, I'm one of the largest glass suppliers in the world, I'll probably sell the glass or some of it, right?
Yeah.
Okay, selling some of it or all of it versus none of it is beneficial for me.
It's a difference.
Right? So I kind of look at it and go, so I think for us, we look at it and say, we've got capability through this chain, be it glass, be it material production, be it material conversion, that can enable Tree to go quicker, because that's really the key thing. The key thing, I mean, in these markets, material conversion and launching new solutions takes a long time, and it's hard work. Best to have some friends to help you in that process.
Yeah. Figures.
Yeah. And it was not that we didn't have friends yet, and it's also right. But we didn't realize that they have quite. They also have friends which could help us with
sure.
right?
Friends are friends. Yes. Yeah.
No, so if you just see the amount of partners, let's say in the wind energy, let's say sector is already, and then we're the direct parties who we work with are already over 10, and then if you look at the supply chain, I think there are maybe like 15 or something that we work with just to make sure that, and then then we had one major, let's say, okay, what if we scale to, for one wind farm, for those who don't know, it's like 5,000 tons of composite, which doesn't, if you don't know what that is, but it is that you have to produce, let's say, in 6 months.
Mm-hmm.
So then it's at a certain point 5 to 10,000 a day. And then it just, what does it mean that you would, for example, have glass, but then also a truck of 10,000 liters of resin being, let's say, injected at a day, as in, and then you start to think about, you really need to look at, right now, how do you scale to that point?
Yeah.
And the choices that you make in material, but also in processes in terms of scalability, you have to do that right now, and you have to discuss with the partners that scale with you how you're going to do that.
Yeah.
This is what we are going to, let's say, strengthen, I think, because we already think about it from day one. That's why we switched from hand lamination to a VI process. But now I think we are going to, at least I think, to make it very simple, we're going to make our lives a little bit more
Easy.
That's actually the whole intent, that we make what we do a little bit more easy by just also bringing in all of the experience about what did work in the past, but also what are the consequences for certain choices if you're going to go to these scales and volumes. And and I think that is really why I'm happy that we are not going to take on this challenge alone.
I can imagine.
Chris, but I think there is one point which is noticeable, right? Which is kind of different with Tree than you see in a lot of startups. I mean, I think the ecosystem you've built all the way through the value chain is quite interesting and it's quite special. You know, so I mean, I think I was lucky enough to be invited to go to Amsterdam to stand on the stage and watch the banging of the gong. Right?
Yeah.
But it was intriguing for me in terms of the breadth of the ecosystem that's been assembled by Tree to actually enable this adoption. Yeah. And that's the difference.
Yeah.
Right. And I think that really is going to, that will make a big difference to the speed and the adoption of this technology, because often people are focused on the material and they don't understand. I mean, it's all about the value chain. Yeah. How do you actually configure a value chain to make this work?
Exactly.
So it's great to see.
But to wrap this episode up, Chris. No, not sorry. No, it's very interesting. But we have to wrap it up.
Yeah, we can talk for hours.
We can talk for hours. Yeah, sure. If we look, I mean, Owens Corning is the leader in this respect. So you have a perspective on where the world is going, I guess. If we look at 10, maybe 20, but let's start with 10 years ahead. How do you see this whole thing develop?
I mean, Maxim talked about it earlier. I mean, I think when you look at the predicted growth rate of wind energy, I mean, I've lived it for 16 years now, and it's always this. We always have this joke about, okay, what's the gigawatt install going to be next year? Because whatever you think it is, it's not that, right? But the line goes up. Now the point is, the gradient of the line is starting to change. So you start to look at it and say, okay, if you project forward 10 years, the scale of the wind energy market is going to be astronomical, right? It's going to be a significant, it could be 20, 30, 40% of the overall composites industry.
Yeah.
A lot of that's offshore.
Yeah.
Right? A lot of it's offshore, particularly in Europe. Yeah. I mean, in Europe, pretty much all of it's offshore, right? So you kind of look at it and go, I think you're going to be in a situation where you're going to have a bigger wind energy market that's going to require very efficient production processes, because these blades are enormous. I mean, if you've never seen one, they're enormous, right?
Yes.
And they're only going to get bigger, and the towers they're going to go on are only going to get bigger, right? And I think this point of you're going to see this opportunity to actually create a market that's going to be transformational, but also significant in scale, which I think is super interesting. So I think for me, that's how I see the 10 years. And I think what we'll also see, we'll start to see the adoption of composites into more building construction infrastructure type applications, because the value proposition makes sense. And I think, unfortunately, there's areas of the world where there's infrastructure that needs to be rebuilt for certain reasons. Mm-hmm. And you look at it and say, composites, I think, is going to play a bigger role in those areas than probably it's played before.
Yeah. Yeah.
And I think, if you look at it from a traditional market perspective, I think automotive it's kind of, for me, it's kind of peaked.
Yeah.
Right. And I think you look at electric vehicles and stuff like that, they don't have water systems, they don't have oil systems. So I think the trend in composites usage will shift towards building construction infrastructure and renewable energy.
Yeah.
It's going to be key.
Yeah. I cannot add a lot. The only thing that I still have is, because we didn't touch upon it, and I'm quite interested in, at Owens Corning, you do a lot on the sustainability part. Mm-hmm. I just wanted to ask, okay, what are the current trends that you see in that respect?
Composites is an intriguing material, right? You're going to spend your life building structures that are incredibly durable, right? The problem with durable structures is at the end of their life, they're quite difficult to deal with. I think as we go forward, we see that circularity is becoming, today it's a nice to have, eventually it's going to be a must to have. And the question you then have to deal with is, okay, how do I deliver circularity within the composites industry? Okay, so what we do is we think about it in some simple steps. The first one is you have to make sure your house is clean. And what does that mean? Stop putting things in the landfill. Mm. Okay, when we produce glass, we have process waste. Okay, so the point is, what do you do with the process waste? Ideally, the process waste needs to go back in the process. Okay, our customers, our converters, they have process waste. What do they do today? Most of it gets landfilled.
Yeah.
Okay, we have to clean that as well. And then eventually you get to the point of end of life. And then you've got a composite. You don't have glass waste, you have a composite. So then you've got to think about, okay, how do I deal with that? Now, classically, what people have thought about is, I'll just chop it into little bits and I think about turning it into a new material. go back to what we said at the start. I sell specific modulus per dollar. If you chop it into little bits, the specific modulus per dollar is not that great.
No.
Right? So what do you need to do? You need to separate the resin from the glass. You need to put the glass back in the furnace, and you need to produce pristine glass again, which has got the right specific modulus per dollar.
Which makes it circular.
Which makes it circular. So really, our whole process is about building the capability of all of those steps to enable us to actually put the material back in the furnace. And then the fundamental thing you've got is, okay, I've built circularity, but then how do I deal with embodied carbon? I deal with embodied carbon by melting with hydrogen instead of natural gas.
Yeah.
So today we're running our plant in France for an extended period on hydrogen gas to actually look at the implications of how to actually use this at scale. But essentially what we've done is we've produced a 95% reduction in CO2 in the glass material.
95%.
95. Well, it's hydrogen, right?
Oh,
There's bits of the furnace we still need to heat with gas at the moment. But you look at it and go, but really the point is we've demonstrated that we can do it, and we've demonstrated that we can actually put recycled glass back in it. So essentially you've demonstrated circularity.
Yeah.
Now, is it more expensive? Yes, it's more expensive at the moment. Is it going to get cheaper? It will get cheaper with time, as electrolyzer technology improves and stuff like that. But really for us, the key point is we have to have a circular business.
Yep.
Yeah.
We have to have it.
Yeah.
Yep.
So that's the point.
But the takeaway I have is that, although we are, in terms of glass and in terms of composite, we are well underway, but still we are in a very early stage with regard to adapting and then building and constructing and stuff like that. So there's not one world to win, there are more worlds to win.
Yeah.
Is that right?
Yeah.
Yeah, for me, what Chris said is for me personally, that's really important. Because the last thing that I intended to do is cause waste at the end, right?
Mm-hmm.
So I'm really excited about that. We can already have like zero waste during production, that we actually can reuse that. And also, besides, of course, I think the joint on its own even can be reused or repurposed. That's already good. But at the end of the life, that we could reuse the glass into, let's say, the new generation, that's where I get excited. Because then we really do what we want to do is accelerate the energy transition with a low impact on the environment.
And as long as we keep telling everybody this story, I'm sure that they will be excited as well.
Yeah, I think it's about communicating clearly, and I think you look at it and go, it's okay. We're delivering circularity, and we're focused on reducing embodied carbon.
Yeah,
it's not that complicated.
I want to thank you very much, Chris, for coming over from Brussels to sunny The Hague.
It's not sunny anymore.
Not
looks like
anymore.
It's going to rain, right?
It looks like it's going to rain. No, it was sunny when we started. No, thank you very, very much, Chris, for being in Future in Steel, and of course for your explanation of where we are at the moment, and definitely for the explanation where we are going, because that is more exciting. Because the excitement is in the future, isn't it?
Oh, my pleasure. It's been great fun.
Thank you very much.
Thanks.
All right. You've been listening to Future in Steel, a glimpse into Europe's industrial future, with thanks to Chris Skinner and Maxim Segeren. If you want to know how your company can benefit from the composite revolution, or if you are interested in investing and becoming part of this development, don't hesitate to contact 3 Composites. They'll be happy to assist you. And for now, my name is Koos Woltjes, and see you in the next Future in Steel. You have been listening to The Future in Steel, a podcast series about the composite revolution, brought to you by 3 Composites, winner of the 2025 Chamber of Commerce Innovation Award. If you haven't already, please subscribe to this series on your favorite podcast platform, or visit the 3 Composite website for additional resources. Thank you again for listening, and we look forward to bringing you more insight in The Future in Steel.